Say it again.
Linear relationship.
Linear relationship. Will that work for you? Wonderful. Now let's not do maths. Let's do storytelling. Okay? And you can hear me okay, right, Srivatsam?
Yeah.
Okay. So my age is 3 times the age of my elder daughter. Okay? I'm just telling you a story, okay? You are just getting to know about me. Yeah? I'm saying my age is 3 times the age of my elder daughter. Then I'm saying if you multiply my younger daughter's age by 4 and add 7 to it, that is my age. If my younger daughter is 10-year-old, tell me what is my age. Okay, that is here. Okay, so I gave you guys a story. My age is 3 times the age of my elder daughter. And my younger daughter's age, if multiplied by 4, and then you add 7 to it, that is my age. If my younger daughter is 10-year-old, what is my age? And what is my elder daughter's age? So what I'm doing here is, again, don't try solving it. What I'm doing here is, I'm giving a relationship. I'm giving a couple of relationship between two different data, two different information. And then using that relationship to derive some conclusion. What you guys are interested in is, this guy looks old, but how old? That's what you're trying to figure out. Yeah? And that how old is hidden in the story that I gave you guys. And that is exactly what you'll end up dealing with in your exams also, as something called as word problems. Yeah? So now let me narrate my story like a student or like a teacher. How you will solve it or how I will solve it. Srivatsam, you can hear me okay?
Yeah.
You can see what I'm doing as well? If I start dancing, you'll be able to figure out, right?
Yeah.
Okay, wonderful. I will not dance, don't worry. I will only dance on the board. Okay, so the same story that I gave you, I'm repeating myself. My age is 3 times my elder daughter's age. Let's say my elder daughter's age is X. Okay, so this is my elder daughter. Okay, her age, let's say it is X. What is my age? My age is 3 times. My age will be, let's say if it is Y. Y is equal to 3 times this age. This is the first relationship that we have drawn from the story that I have given you just now. Hey Mitran. Hello Mitran, can you hear me? Okay. I assume he can hear me.
Yeah, I can hear you.
Okay. So you are not being recorded here. You can be on video as well. I am recording it only on the iPad. And this meeting is not recorded, as you can see. Okay.
Okay.
So what I was asking was, so today I was thinking that you'll be here in person, but you are online. That's okay. We are trying to learn about the linear relationships. Okay.
Okay.
So that's what I started with, and I just gave a story that you guys are interested to know how old I am. Though I am old, but how old? Yeah, that's what you are trying to figure out. So that how old question we are trying to answer with a story that I gave just now, and the story is that my age is 3 times the age of my elder daughter. Okay, that is first line of the story. My age is 3 times the age of my elder daughter. So let's say my elder daughter is X years old. You guys don't know how old she is, right? So I'm saying she is X years old. And my age is 3 times her age. So if my age is Y, it is 3 into X. Where X is the age of my elder daughter. That's the first line of the story. Yeah? Second line of the story is, or second information that I have in the word problem is, where I'm saying, also my age is 4 times the age of my younger daughter plus 7. You guys don't know how old is my younger daughter either. So you will say, okay, your younger daughter is, let's say, Z years old. So I'm saying my age, which is Y, equals to 4 times the age of my younger daughter plus 7. This is the second equation or second relationship that is there between my age and my daughter's age. Okay? Are you guys with me so far?
Yeah.
Yeah.
Now I am giving the third information through my story, saying my younger daughter is 10-year-old. Find out my age and my elder daughter's age. Can you guys find it out? How? Do you know how?
Forgot the.
You
Yeah.
the steps again. Because with the whole process.
So I'm saying first equation was, yeah.
You would put, since your younger daughter's age is 10.
I'll come to you actually. He's asking me to repeat the question, so I'm just repeating the question for Mithran. So Mithran, I was saying the whole story was like this, that my age is 3 times the age of my elder daughter. My younger daughter, and also my age is 4 times the age of my younger daughter plus 7. If my younger daughter is 10 years old, what is my age and what is my elder daughter's age? That was the question.
Okay.
So while you guys are trying to solve it, Praneeth has also solved it. I'll come to you guys. But before we try solving it, what I'm trying to convey here is, this is a classic example of linear relationship. Meaning, linear relationship between different variables. When you say linear, meaning a relationship which represents a line. Okay? Because if you say linear, if you look at the word linear, the first part of it is line. Any relationship which helps you draw a line on the graph is called a linear equation. We'll talk about that. We'll come to that. Here, I was just telling you guys that the equation, the situation that I talked about, that represents a linear equation, linear relationship or linear equation. How, what, how to do a graph, how to make that line, those things we'll figure out. Okay, we'll learn about that. But in summary, in short, if you want to know about what is a linear relationship, it is nothing but a relationship between two unknowns which draws a line on the graph. Okay? If you want to be more specific, always keep in mind that when you're talking about a linear relationship, you will never ever have the power of any of the variable more than 1. If you see a linear relationship or an equation which says y equal to x square plus 3, this is not a linear relationship. Any equation that has power more than 1 or any relationship that has power only as 1 or 0 is a linear relationship. If it has power other than 1 or 0, It is not a linear relationship. It will not draw a line. It will not draw a straight line. Yeah. Okay? Now the question that I talked about, let's see who has solved and what is the answer. Let me see who all has figured out my age. So Praneeth,
47.
47. Okay. How about you, Srivatsa? What is my age? See,
According to my process, I think I got like, I'm still doing it, like,
okay.
I'm doing it on my, like,
Okay, you finish it, then I'll come to you. Mitran, you also finish it, let me know. Let me see how Praneeth has done
I'm
it.
just solving.
Yeah, you guys finish it, then I'll come to you guys. Yeah. This is right. So now I relate math with storytelling. Okay. I will try solving this equation also here. You have got it right, so there is nothing wrong with that. But I will just tell you guys how do you convert math into a story. Because if you go by the statistics, it is told that whatever you learn, whatever you study, you only retain 5 to 10% of it after a couple of hours. Everything else disappears, vanishes, gets wiped off. But if you hear a story, if you recall when you were much smaller, like a baby, 5-year-old, 4-year-old, you might be able to still recall some of the stories that you would have heard from your grandparents or from your parents. Some fairy tale, some story, where there was a real life situation that was talked about, something happened to somebody, and you are able to still relate. After you figured out my age, 47, I still recall some of the stories that I've heard from my grandparents, who are not there now. But I'm saying, I still remember those stories. So stories are something that lasts with us longer. Whatever we learn, let's say if you're learning, let's say chemistry or biology, whatever you have learned, stitch that like a story for yourself. Okay. Let's say if you talk about photosynthesis, okay, photosynthesis is where you get the sunlight, you get the minerals and the water from the earth, and then you get chlorophyll in the leaves. This together makes does the photosynthesis and makes more product or food. Make it like a story. That okay, there was a family of 5 where you had chlorophyll as one of the child, sunlight as the father. Mommy was cooking food by taking minerals and water from the ground. I'm just making it up, right? I'm saying that whatever you learn, if you relate that like a story and try visualizing it, trust me, that lasts longer with us. Okay? Any concept, any theory that you learn, any practical problem that we'll come across or formula that we'll learn how to derive, we'll try to put it like a story, and then you will see it lasts longer with you actually. Okay? Let's see if Mitran and Srivatsa are ready. Are you guys ready with my age?
I think yeah.
Go ahead.
My
Go ahead.
answer is different, I guess. So,
How much is that?
don't laugh, but it's like 34 or something.
I feel much younger.
Oh,
Okay, we'll come to that. We'll come to that. And I will, like I was saying that, every math that we do, everything that we learn ends up being a story. And I'll convert that like a story, okay? I will literally do storytelling for you guys, okay? Now let's say Mitran, what is your answer?
Well, what I did after I'm done with the math, after I call X, I add the X up with the other age, then I got 47.
Okay. So now you guys know the age. You guys are making me feel older and younger at the same time, but that's fine. That's okay. I mean, that was not the intent. It was not. I was not trying to prove anybody right or wrong here. The intent was to make you guys understand what is a linear relationship. Now, I have been bragging about the storytelling for some time. Let me tell you guys what I mean by that. Let me try doing that sum as a student, okay? And let's see how close I get to my own age. So if I'm trying to solve that, yeah, Mithun, go ahead. Okay, if I am solving this sum, right? The sum that I was asking you guys to solve, I will read the question again and again, and this is what I got. That my age is 3 times my elder daughter's age. So I don't know what is my age. I don't celebrate birthday. So I don't know what is my age. But I know the formula which says my age is 3 times my elder daughter's age. Okay. My age. Let me say M for my age, let's say, is 3 times my elder daughter's age. Let's say my elder daughter's age is E. Elder daughter, okay. So 3 times my elder daughter's age. Okay, fine. This is one equation I heard or understood from the question. Second line says my age is 4 times. My age is 4 times the age of my younger daughter. So let's say Y is the age of my younger daughter. E is the age of my elder daughter. So here first equation is M equal to 3 times E. Second equation says my age is 4 times my younger daughter's age plus 7. Are you guys with me so far?
Yeah?
Yeah.
I'm just writing the story here, okay? Now, if my younger daughter's age is 10 years, meaning my younger daughter's age is 10 years, I got my first clue here. What is my age and what is my elder daughter's age? Now, let's see. I know that my younger daughter's age is 10 years. That's what the question says. I will substitute that in this equation, where my younger daughter's age and my age is related. This is the relationship. Okay? And this is a linear relationship because any of the variable that you see has maximum power of 1. M has a power of 1, Y has a power of 1. If there is nothing, that means that is 1. Yeah? Now I will put this value in this equation. So M equals to 4 into Y plus 7. That was the relationship I knew, which is between my age and my younger daughter's age. That means 4 into, that means M equals to 4 times 10 plus 7, which is equal to M equals 4 into 10, 40 plus 7. Or M is 47. So if you look at this whole thing that I have done here, I was telling the story, okay. So age of my younger daughter is 10 years. I am putting that value in this equation, which says M equals to 4 into Y plus 7. I did not put 10 here in the first go. I put the equation first, which is my thought process. That okay, I am going to substitute here, so let me put the equation first. That means M equals to 4 into, instead of Y, I put a 10. Or, and hence, M equals to 4 into 10 is 40 plus 7, 47. So in this equation, in whatever I have done step by step, I was actually telling a story. So M equals to this. So now I'm replacing Y with 10. This is what it becomes. 4 into 10 is 40 plus 7. So M equals to 40 plus 7, 47. If you keep it this explicit while you are solving it, or when you are doing the scratch work before selecting the answer, this actually gives you a very clear view into how you are doing the calculation step by step. If you go wrong anywhere, let's say 4 into 10 you end up calculating 39, then you would know, okay, from here I was supposed to have 40, I put 39. I made a mistake here. So you'll correct it there and then you'll continue. So that is why we end up doing a lot of mind maths, which is very much needed because that makes you do things faster. But while doing the scratch work, try working on increasing your speed a little bit so that you do the scratch work a little comprehensive. It gives you the ability to do your review, and then do the correction whenever you find a mistake. Again, I might do that in 4 steps, you probably will be able to do it in 2 steps also. And that is perfectly fine. It's all about how fast you can do it, but you to make sure that the way your brain works, you are painting a picture of that in your flow. So that way you can relate to what you have to review, right? Because in any exam, if you let's say got 20 questions to answer, you finish them all, you have 20 minutes or 10 minutes left. What you do? You do review. How will you do review? This is what you will do, right? To make sure that even if there is a possibility of going wrong in one place, you are killing that possibility. Okay? So, I gave a lot of theory here, but let's do a recap. What we are trying to learn today was linear relationship. Linear relationship is nothing but a relationship between 2 unknowns, 2 variables. It could be 3 variables also, but mostly you don't deal with all the variables in one equation. You will not say y equal to x plus z plus c. That is too much to deal with. Mostly you will see the equations that we deal with have 2 variables. That's what would be the starting point for you guys, at least in the up to the 8th grade. Once you go to higher classes, you'll end up dealing with more. But simply put, a linear relationship is nothing but a relationship between 2 unknowns, which depicts how they are related to each other and how you can use information from one variable to get the value for other one. So let's say, now let's play with that a little bit more. But before we do that, any questions, Mitran or Sivatsa? Anything that is not clear?
No.
Sivatsa, are you clear about what I was saying? Okay. And you both got to know about my age also. Yeah? All of you. Okay. So I'm a little more than that. I'll be becoming 48 by April. So I gave you guys enough clue. I'm still not 48. I'm just trying to defer that 48 for a few more months. Alright. So coming back to the linear relationship as we discussed, it is nothing but a relationship between 2 variables in a linear form. What is linear? When you say linear, that is nothing but line plus AR. Yeah? So when you talk about linear relationship, it simply means that something that will plot a line. That's what is linear. Okay? Now let's look at that. How it plots a line. Let's pick up an equation y equal to 3x plus 7. I am claiming that this is a linear relationship because there is no power 2. There is only power 1. Here also there is no power 2 or 3 or 4. Only power 1. Okay? So I am claiming that this is a linear relationship, meaning it will plot a line when we try to plot it on a graph paper. Do you guys want me to prove that? Let's do that. Yeah? So do you guys know how to plot a graph with the equation? Srivatsa, Mitran, do you know how to plot a graph with the equation?
Yeah.
I
No?
guess no. I think I forgot it.
Okay, so let's do it. I mean, I do it like a baby always, right? So let's do it like a baby. So this is a graph. Again, why do we need a graph? Because graph gives us the ability to locate points. If you imagine that these 2 lines were not there, if I say a point here and a point here, joining them will make a line. I'm still talking here. Because I have no way to locate this guy. I don't know where it is. Is it here? Is it here? Is it here? I don't know. Because if you try locating any point, it is always with respect to a reference. Let's say, if I say, I live here, that here has no meaning. When I say I live in the suburbs of Dallas, I am giving Dallas as a reference point from where my house is, it can be located. So graph, here if you look at these points, right now we don't have a mechanism to locate where these points are. If you are coming to this class, what you need to do, you have to give your starting address and give my address. To draw a line between your place and my place, and you drive. It will not be a straight line always, but at least you have starting and ending point. So here, the most important thing is you should be able to locate these points from where to where, and that ability comes with the graph. Graph makes it more explicit. Now, let's look at this. If this was the page and you were trying to locate these 2 points, okay? Now it's easy. See, what you will do is, you can see, okay, this is my x-axis here, this is negative of x, this is y-axis where it is positive here, and this side is negative of y. Now, if you have to look at this point, what you will do, okay, how far is this point from the x-axis and from the y-axis? So, this is one distance, this is another distance. That helps you locate this point. If I try locating this point, what I will do, okay, how far is this from the x-axis, how far it is from the y-axis? It helps you locate this point exactly where it is. So, now if you imagine your travel from your home to this class. What did you do actually? You gave this place location and your location, and again your location can be found in the Google Maps that has a x and y axis, and my address has a x and y axis. So now my address and your address is locatable, if I can use that as a word. Okay? And then you connect those points to figure out how will you travel. So it's very important to locate a point. So how you locate that point is here in terms of a graph, you find the x value of x, meaning how far it is from x or y axis. That helps you locate that particular point. So if I look at this point, let's say this was 1, 2, 3, 4, 5 in the graph. 1, 2, 3, 4, 4. Let's not make it 5, 5. Let's say 1, 2, 3, 4, 5, 6. Okay. Now look at this point. This point is 5 units away from the origin. This is the origin, right? So this is 5 units away on the x-axis, and how many units away on the y-axis? 1, 2, 3, 4. 5, 4. If you just tell this 5, 4, you will be able to look at this point. It simply says, this is my value on the x-axis, this is my value on the y-axis. And these values are called coordinates, x-coordinate and y-coordinate. So if you look at any two-dimensional space, if you want to know me where I'm putting my thumb on this floor, you will look at this as a graph and find out the x and y coordinate of my thumb. That will be the point to locate. Likewise, in the Google Maps, you should see there is x and y coordinate to locate that particular place, and that is unique. Your house's x and y coordinate and my house's x and y coordinate will not be the same unless we are living in the same house. Okay? Same. Yeah. Yes, Srivastava, you are saying something?
No, I was just agreeing.
So now I got the x and y coordinates here. Whenever you see any point on the graph, you just need to know the x and y coordinate, and that is the only way to locate that guy. It says, okay, how far it is on the x-axis, the first point, how far it is on the y-axis, the second point. On the y-axis, that is the y coordinates. Now let's say we are talking about this guy. Same thing. Let's say 1, minus 2, minus 3. Let's say this is minus 3. And here it is minus 1, minus 2, minus 3 here. So this is, let's say this is somewhere around. So let's look at the x and y coordinates for this guy. On the x-axis, this is on the negative side. So this is, let's say, minus 2.5. So minus 2.5. What is the value on the y coordinate? Again, this is also minus side. And this is cutting somewhere around 3. So minus 2.5 and minus 3. These are the two coordinates, x and y coordinates for this point. There is nothing magical about this one. I am just trying to locate 2 points and find out the x and y coordinates here. That is how you will be able to relate it in future when we talk about drawing a line. So again, we started with the point that if I have a linear equation, if I am claiming an equation to be a linear equation, it will draw a straight line for me. So let's do that thing with the equation that I had put. I had mentioned y equal to 3x plus 7 if I am not wrong. Be it 3x plus 7, be it 3x plus 21, doesn't matter. This is just a linear equation for me, where the power of the variable is 1. So I am claiming this is a linear equation. Let's see if it is there or not. Now, do you guys know how to plot this line on the graph? You know? Okay. You guys, Mitran, you also know, Srivatsam, you also know, but you probably might have forgotten. Let's plot it right now to prove that this is a linear equation.
What's that? I can't see that. I can't see
y equals to 3x plus 7 is my linear equation.
Okay.
Which I am trying to draw here. So let's say this is 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4. This is 1, 2, 3, 4, 5, 6. Here it will, let's say minus 1, sorry, this is 1. 1, 2, 3. Here it is minus 1, minus 2, minus 3. Now, let's try plotting this line. Let's try plotting this one on the graph. What is the way we do it?
You plug in your x.
I'm sorry?
You plug in an x value.
Okay, yeah. And what is the easiest way to do it?
1.
Even 0.
0, yeah.
Let's say, what is the value of y when x is 0? So I'm trying to find out a point where x equals to 0. And what is the value of y? I'm trying to find this using this equation. If I'm putting x equals to 0, meaning 0, what is the value of y here? 3 into 0 plus 7. I got 1 point. Okay? Let's put another value, like what Pranit was saying. I'll put a 1. If I put x equals to 1, what is the value of y?
10.
10. And if I have to draw a line, I can just draw it with 2 points. Okay. Here, I will probably use another one. Let's say, let's put y equals 0. I'm putting y as 0. What is the value of x in that case? If y is 0, x will be equal to minus 7 by 3.
Let's see. Minus 7 divided by 3 is. Yeah.
Agree?
Y equals to 0, then x would be negative
7 by 3.
Wait, let me check my work. Negative 2.5.
No, negative 7 by 3. Y equals to 3x plus 7.
Minus 2 and 1 third. So it'd be.
Oh, so it's negative 7 by 3.
Yeah. Yeah. So basically now I have 3 points. Let's see if I can plot this on in this graph. First point is 0 and 7. So 0 and 7. X's value is 0 on y-axis here. And anywhere you pick, it will be 0. 0 and 7. So it will be somewhere here. Okay. Let's say 1. This is 1, 2, 3, 4, 5, 6, 6, and this is 7. So 0 and 7. This is my first point. x is 0, it is 0 and 7. This is my first point. Now let's look at the second one, 1 and 10. When x is 1, it is 10, somewhere here. Third point is minus 7 by 3 and 0. So minus 7 by 3 will be little more than 2, somewhere here, and 0. So yeah, this is the point. So when you join these lines, these points, you will see that this is a straight line. I mean, though here I could not do it, but any equation, any linear equation, try plotting it on a graph paper. Okay, pick 2-3 values of x and see what is the corresponding value of y. So that becomes your x and y coordinate. Whenever you plot them, you will see that it forms a straight line. So that simple thing, simple formula to remember is always that any equation or any linear equation means, I would not say linear equation, I would say any equation or any relationship means how the two variables are connected with each other. Okay? When you are saying linear, that means that relationship is going to form a line on the graph. A straight line on the graph. Okay? These are the two things that we have to take into account. Now, how are we plotting the graph? It's very simple. Put that equation, put the value of x as 0, 1, 2, whatever simple values, okay? And find out the corresponding value of y, and that becomes your x and y coordinate. Use 2-3 points, try plotting the point, try identifying the points and connect them. If it makes a straight line, that is a linear equation. And if you have any equation like this where the variable of any of the variable doesn't have any power other than 1, that is a linear equation. If that is not the case, I'm not teaching you right. I mean, it's an axiom. It's a proven fact. You can prove it over and over again by drawing it on the graph paper. And if ever you come across a linear equation which has power 1 and then it starts forming a straight line, I am to be held accountable for that. Okay? Yeah? Any questions before we move forward?
I don't have any so far.
Okay? How about you, Srivatsava?
No.
Clear?
Yeah.
One line about the linear equation is any equation which has power of 1 for variable has to form a straight line. If it is not doing that, it is teacher is wrong. Okay? It cannot be. It can't be. Now, since we are talking about linear equation, there are two forms of linear equation that you guys are supposed to know. I'm not sure if that is already covered in your syllabus or not, but when I teach kids for SAT preparation, I make them aware. So there are two forms of linear equation. Do you guys know? Anybody remember? Recall? What? Yeah.
I believe there's one about like the line goes through the origin,
Okay.
and the other one there's a y-intercept.
Yeah. So there are two types of equation that you will talk about. Y equals to mx plus b or c. This is called slope-intercept form, and second one is called standard form. Ax plus by equals plus c equals to 0. This is called standard form. This is called slope-intercept form. Any and every linear equation will align with one of these forms. In fact, these two are also related. I can convert this into this or this into this. Here, if you look at the slope-intercept form, this is called the slope-intercept. This decides how steep or shallow the line is. Yeah? And this is the intercept, meaning where it hits the y-axis, where it cuts the y-axis, meaning when the value of x is 0, at what point on the y-axis this line touches. Okay? So this is called slope-intercept form. We'll go into detail of that in the whenever we learn about this one in detail. But the other thing that we need to be aware of. So any linear equation you talk about, you can map it to one of these forms. If somebody says, okay, there's an equation saying 5y plus 3z plus 9 equal to 0 or minus 9 equal to 0. Again, it doesn't have to be x and y always. What it means is there are two variables. Here y and z are two variables. A is the coefficient for the first variable, b is the coefficient for the second variable, and c is the coefficient for the constant. C is the constant basically. Yeah. Any questions so far?
No.
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 Okay. And now slope intercept form. Let's break it down a little bit. So when you say slope intercept form, the most important thing is water. Let me take a sip. So when you talk about a slope intercept form, or don't talk about it. Talk about a straight line. Let's say I have a graph. I'm plotting this line. I need to buy these markers. They are running out of ink. If I have a graph, if I plotted a line, this line, or this line, or this line, or this line, all these lines are different. They are lines. They are representing a linear relationship, but they are different. How? This guy is steep. This guy is going down. This guy is moving upward. Yeah? They are cutting the x and y axis at different places. That is the behavior. That is the property. That is the difference among them. We are all human beings. But is Mitran and Biren the same? Is Srivastava and Pranit the same? No. We have different properties. How we get identified, what is our age, what is the behavior, do we wear glasses, do we not wear glasses, who is how tall, right? There are different parameters, different properties that makes us unique. So is the case with the lines that we are seeing here. They all have different properties. Just by seeing this line that I have drawn here, you can see that yes, this line is cutting very close to the origin. That is not the property. Yeah? This line is moving upward. This line is also cutting very close to the origin, but this is going downward. What downward and upward means? If I increase the value of x, value of y is increasing. If I increase the value of x, see the value of y is increased. Yeah? If you look at downward, what does it mean? If I am increasing the value of x, here it was x was negative, I am moving towards positive x, but y is becoming negative. So y is going down. Yeah? Negative slope. So if you look at a positive slope, in theory, in story, like I always get tempted to say, positive slope means things are moving positively. Things are moving upward. Increase one value, other value increases. That is a positive slope. Decrease one value, other value decreases. That is still a positive slope. Meaning, when you are decreasing it, it's decreasing. When you increase, it will increase. But a negative slope means when you increase something, it decreases. It's like a crypto market or a share market. You invest more money, you lose more. I'm not discouraging anybody from using stocks or cryptocurrencies. What I'm saying is, a negative slope means you put more, you end up losing more instead of. It's like people go to casinos. They'll put some money, like me, and they will lose. Okay, no, I have to recover that. I'll put more, and I end up losing more. So the negative slope is like a casino. You put more, you lose more. Okay? Not always, but most of the times. A positive slope is like farming. You take more care of your farm, you put more fertilizers, you water them on time, the plants grow. So that is a positive slope. When you increase something, you are increasing your effort, you are paying more attention, you are doing more work. Your outcome is also in the same proportion. If you are talking about negative slope, it means you put more, you lose, end up losing. You are not getting any return. So that is what the negative slope is. Here the value of x is increasing. Earlier the value of x was positive. If you are moving towards the, earlier the value of x was negative and the value of y was positive. When I am increasing the value of x from more negative to less negative, meaning increasing, then moving towards positive, see my y is correspondingly going down. So that is negative slope. So negative slope simply means when you increase one of the variables value, the other variable's value decreases. That's a negative slope. Positive slope is when you increase one value of one of the variable, the other variable's value also increases. That's a positive slope. Now, any questions? No questions?
No.
No questions? Mitra, any questions?
I don't have any.
Okay,
I
wonderful.
don't have any.
So, if you guys don't have any question, I have questions. So, if in a graph, I have plotted line like this, is it a positive slope or negative slope? Okay. Mitran and Srivatsam, is it a positive slope or negative slope?
Can you draw the line again? I can't see.
Yes, Sam, I can't see it clearly.
You can see it clearly.
Yeah, it looks too far away.
It's positive.
It's positive.
Yeah.
Okay.
Yeah, it is positive.
It is positive. Okay. You not have any doubt, right? Now, let me play with it again. So in this graph, this line versus this line. So this is line A and this is line 1 and line 2. Which one is negative?
It's line 2.
Line 2 is negative? Okay, very nice. Do you agree, Shivatsar?
Huh?
Which one is the negative slope? Line 1 or line 2?
Oh, it's line 2.
Line 2. Very clear, right? So if the line is moving from top to bottom, this is going down, negative, loss. If the line is moving from bottom to top, things are increasing, things are becoming brighter, value increasing, the positive slope. Okay. Now, so we talked about the slope enough. Now, when we were looking at this equation y equals to mx plus b, we were talking about this part so far. M, the slope. We'll figure out what is the value of m, that also we'll figure out. But at least by looking at the line, we'll be able to figure out is the slope positive or negative. Yeah? Now, second part of this slope intercept form is called the intercept. Y-intercept. What is that conceptually?
It's where your line meets your
Y-intercept. Yeah. Okay, Mitran and Srivatsam, what do we mean by the y-intercept here? Let's say if we talk about
The y-axis?
This is the y equal to mx plus b. I am putting y equal to 3x plus 8. What is the intercept here? What is the y-intercept here? And what is the meaning of it?
Oh, B. It's also known as the bonus.
No, b as in bonus, but here there is a slope intercept form. I have put a corresponding equation in the same form. Yeah.
I think it's I couldn't see, but I think it's plus 8.
Plus 8. Now, y-intercept is plus 8. What is it? What does it actually mean?
So it's like like a head start or like a,
Okay.
like
What?
it is a number on the y-axis.
It's a number on the y-axis, or the way I will read it is
where your line intercepts the y-axis.
where your line intercepts the y-axis.
Oh.
So, or if you want to know it like in another way, you will say this is where the value of x is 0. So here in this equation, okay, where it intercepts the y-axis, where it will intercept the y-axis, on the y-axis the value of x is always 0. On the x-axis the value of y is always 0. They are like enemies. They don't go together. If you are on the x-axis, y is 0. If you are on the y-axis, x is 0. Okay? So when you look at this as a y-intercept form, slope-intercept form, this tells this is the value of the y-coordinate, or this is the point on the y-axis where it will cut your y-axis. This is where it will intercept the y-axis. That is why if you break it down, this equation as a slope-intercept form, you talked about relationship between y and x with this as the slope and this is the intercept. That's why it is called slope-intercept form. Yes.
It's also the last place where your x value would be negative.
It is the last place where the x value will be negative now.
No, wait. Afterwards, like moving down or up, your x value wouldn't be negative anymore.
No.
Afterwards.
So moving down will be your x value negative. Moving up will not be.
Moving down still, if this is
Uh-huh.
your x would still be positive.
So if you are coming here, if you are coming down, your x is already going negative.
Yeah.
If you are moving up, so this is the last point where x is not negative.
Yeah.
If you increase x, it will be. Now you look at this equation.
Even out.
In this case, what's happening? If you are going up, if this is the slope is negative, then if you are going up, meaning if you are increasing y, your x is becoming negative. If your slope is positive, then increasing x makes your y also, and increasing y makes your x also increase. So there is no relation here. I mean, we can derive some based on what we see. I mean, I will probably invent a new theorem saying, okay, if it's in a slope-intercept form, if it's a negative slope, then after this intercept, by decreasing y, only x increases. If it's in a slope-intercept form, if it is a positive x, increasing y increases x also. I can derive that as a theorem, but that is more of an interpretation, not a theorem, I would say. Yep. So in a slope-intercept form, there are two things that we need to keep into account. One is called slope, which defines which way the line is going, whether it's a positive or negative slope, and the intercept where it is touching the y-axis or intersecting the y-axis. Anything you would want me to explain before? I mean, any doubt so far before I move forward?
I guess no.
I have a question.
Yes.
So, for the y equals to 3x plus 7 part, if you put 0, if x equals to 0, so that'll be, that would be 3 to 0 to 0 plus 7, which y will equal to 7. Would that be the x and y coordinate 0 or 0 and 7? Or
Yes.
is it something else?
Yes, it will be 0 and 7 will be your x and y coordinate.
Okay. I'm
Now-
just making sure.
Right. So here, now comes the bigger point. Now if you look at an equation, a linear equation, where you are putting value of x and getting the value of y. You put value of x as 0 and you got a corresponding value of y. you put another value of x, you get a corresponding value of y. And depending on how you're changing x, you're getting different values of y. It's a relationship. Okay? It's like our parents say, you do the household chores, you will get $2 more as a pocket money. It's a relationship. What that means, if you don't do household chores, you'll not get $2. Yeah? Same thing here. This relationship y equal to 3x plus 8 that you were seeing, x and y value cannot change randomly. They are related to each other. You cannot say that, okay, my x value is 2 and y value is 32. You cannot have unrelatable values for x and y. They are related, they are closely coupled. They have an agreement among them. That's why it's called linear relationship. You cannot say that, okay, this is my equation and my value of x is 3 and value of y is 14 or 16. This may or may not satisfy this condition actually. You have to validate before you say whether this point is lying on this line or not. Or whether this is satisfying this linear relationship or not. Both ways. If you say a point is lying on the line or not, or whether that point is following that relationship or not, you have to validate that. And if any point follows that relationship, that means, let's say if you are drawing that line on the graph paper, this point will be somewhere here. It has to be on the line to satisfy this condition. If it is not falling on this line, this guy, that is not going to satisfy this condition. Or that is not justifying that relationship. Am I making sense? Okay. Mithran, did I answer your question?
Yeah.
Okay. Alright. So we played with we understood the linear relationship, what is that theoretically. We also learned how do we use the linear relationship for drawing lines. We also kind of did post-mortem of the y-intercept form, the slope-intercept form equation. We also learned about the standard equation for linear relationship. And we kind of got little deeper into what a slope-intercept, what are the different constituents of a slope-intercept form, what a slope means, what is a positive and negative slope at a concept level, what is an intercept. We did draw some lines and we were kind of trying to relate. Now in the class tomorrow, we'll do a little bit of more of a double click of that slope, that m thing. Y equal to mx plus b or mx plus c, whatever it is. That m, let's do a little bit of more of post-mortem of m to know what is the relevance of this guy. See, whatever I'm teaching you guys right now, I can tell you with a guarantee that you guys knew it already. There's nothing new that I'm teaching you. But how you relate that math with your experience is what we are doing here in the class. Now if you see a slope like this versus a slope like this, you would know which is my positive slope versus negative slope. And what does it actually mean practically? My positive slope means if you increase one, other one increases. Negative slope means you increase one, other one decreases. That's the basic interpretation. So that is how we relate things, okay? Don't ever dare to believe your teacher on his or her face value. Math is the only subject where you can always validate by yourself. If I say something wrong, it is recorded and goes on to YouTube. You watch it, and if you find a reason to contradict me, do so, because math gives you that ability to do. Okay? That's where I will stop. Any questions before I say we are good for today?